Okay, so let us continue today. Today we will discuss graphical concepts. Graphical concepts. Graphical concepts. So in the graphical concepts, there are few important concepts which we can understand from the graph. So first concept is slope. Slope. Slope of a graph. Slope of a graph. Second is area. Before area, I think shape. Slope then shape. Shape of a graph. Slope, shape, area. Area under a graph. So in any graph, these three concepts are important, and starting from this chapter kinematics, we have lot of applications of this. So lot of applications are going to happen. So slope is nothing but single differentiation. We should understand here. Slope means dy by dx. Dy by dx. Shape is not directly equal to, but it gives the idea of double differentiation. Double differentiation d square y by dx square gives the idea of the shape of the graph. And area under the graph, that is called integration y dx from x1 to x2, right? And there are other things like RMS value and average value. All these things can also be calculated. So if you want, you may note these two extra point also. Average value, average value, and RMS value. Average value, RMS value. So average value is defined as integration of y dx between the limit x1 to x2 divided by delta x. This is called average. We will discuss more detail. And RMS value is defined as root under integration of y square dx. Root under integration of y square dx. X limit is x1 to x2 divided by delta x. Okay, so these definitions, average value, average, and RMS is called root mean square. Root mean square. Root mean square. So RMS and average value, they have also got applications in the physics. Lot of applications are there. Okay, so let us start one by one these concept. Okay, so let us start one by one. Slope, concept of slope. So suppose if you take a graph, any graph is between two quantities x and y. How these quantities are related, how x is changing and y is changing, that graph represents. And graph is a very nice concept, because by writing equation you can also show, but by showing graph it is like a picture. It is always, suppose for example somebody is telling you some stories, right? So you may listen to it, but you may not enjoy. But suppose somebody shows you some movie, then you will enjoy it, because in the movie you can see everything, picture and all that. So same thing is here. So in physics all those equations are there, but when you draw the graph it shows a full picture what is happening. Okay, sometimes the graph may be complex, so we cannot draw that, so you can leave it. But sometimes graphs are easy to draw and we can see the variation in the graph. That is why it is important. Okay, so let us understand that graph is there and x and y are related. It is called function. So y is related with x. This we say that y is a function. Y is a function of x. That means what? That means y depends on x. Y depends on x. Okay, So y depends on us. There is a relationship between that, but relation is different than a function. Relation means just relation between x and y, but function means there is a unique value. Unique value. Let's understand this with a simple example. Suppose if I draw a graph like this. This graph is between x and y. Okay, and if I suppose if I draw the graph between x and y like this, um, two graphs I am drawing. Okay, now out of this graph, one is a function, other is not a function. How do we know that? Suppose if I draw a vertical line, this vertical line is cutting more than one point. Okay, here if I draw a vertical line, it will cut only at one point. That means for a given x, we have only one value of y. So if you take one x value, you will get one y value. But if you choose one x value here, you will get two y values. You can see that there is one y1, there is one y2. Okay, two values of y are there for one single value of x. So this function, this is not a function. Okay, this is just a relation. Okay, it is a relation. It is not a function, not a function. Okay, what about this? This is a function. This is a function, and all functions are relations, so they are definitely relation. So all relations, all functions are relation, but all relation is not a function. A special type of relation is called function. This type of relation where one value of x will give only unique value of y. Okay, one value of x, two values of y should not be possible. Okay, that is what it is. But note here that in this case we can have two values of x. Like for example, here suppose this is x1 and x2. X1 x2, two values of x can give the same value of y. That is okay, that is possible, but we cannot have two values of y for a single value of x. That is what it is, huh? So this is not a function, that is a function. So all the graphs which we draw is mostly for function, mostly for function. For example, suppose if a body is moving, right? Let us say if a body is moving, it will have a unique position at a given time. At a given time, it will have only one position. It cannot have two positions. For example, right now you are in your home. You cannot be at a school right now. You are only at one place. Okay. So you cannot have more than one place at the same time. That is what it is function. Okay. So the various relationship are functions in kinematics, but sometimes it may not be. That is a different case. But mostly it will be function. That means here suppose if I draw y is like position, x is time, y is velocity, x is time, y is acceleration, x is time. Mostly we take x-axis as time axis and y-axis are other variables. Okay, but anyway, general understanding we should have. What is general idea, general knowledge? Suppose any graph is there. This graph is a function. Okay, this is function. Now for this function, suppose if I take any point, if I take 2 points, first of all let us understand 2 points. If I take 2 points, okay, these are two different points. This point is called point A and this point is point B. Okay, now if I go from here to here, let us understand this. So here to here if I go, so there from A to B we have to change the value of x, so that is called delta x. And here to here when you go, you have to change the value of y. Okay, that is called delta y. If you want, you can write this x A as x1 comma y1, or you can write x comma y, x comma y. So you need to change x and you need to change y to go to B. So it is x plus delta x comma y plus delta y. This is the coordinate of A and B. So if you want to go from A to B, and suppose you have to only move along x-axis and y-axis, so you have to go delta x along x-axis and delta y along y-axis. Or if you want, you can go first along y-axis. If you want, you go along y-axis first, delta y, right? And then you go along x-axis, delta x. The idea will be same. You need to go either along x-axis, then y-axis, or first along y-axis, then x-axis. So you have to move only like in a straight line, like a rectangle. Okay. Okay. So now let us say that, yeah, yeah. Oh, B is not visible. One not, one not. B is not visible. X plus delta x, y plus delta y. Check it again. It is coming. One not, one not. I think in your mobile, how are you keeping it? Are you keeping full screen? Here it is visible. Hmm. Once you log in again, please log in again. Tell me, are you able to see? Might be in your mobile. Check. Can you see now? Okay, okay. I brought it down. Fine. Okay, so okay. So clear. Are you clear about this? So to go from A to B, you can go either along x-axis and then y-axis, or first along y-axis then axis. So there will be some changes along x and y. Clear? Hmm. Okay, now suppose if I join a straight line, I make a straight line joining A and B. Okay, I am making a straight line joining A and B, and this straight line is making an angle theta with the x-axis. These angles, all these angles are theta theta. So that means if I make a line parallel to x-axis, this angle will be theta. Okay, this angle will be theta. So a straight line joining the 2 points A and B, right? If I make that straight line, then this tan theta is called slope of the line, slope of line AB, slope of line AB, and this line AB is called secant line. This is called secant line, secant line. So this tan theta is the slope of secant line, slope of secant line. And tan theta, from this graph you can understand what is tan theta. Tan theta is nothing but, what is tan theta? Tell me, what is tan theta? This triangle, what is tan theta? Yes, Ritupurna, what is tan theta in this triangle? Right, delta y by delta x, correct. So tan theta has become delta y by delta x. This is what is the slope of the secant line. Okay, now suppose if I say that the point A and B are very very close, very very close, that means the change in x or change in y is almost very very small, means negligible. Okay, so let us draw another graph to understand this. When the points A and B are very very close, so xy graph, and let us say this any graph is there, and let us consider that these points are now the same points. Very very close means, here you can say that it is very very close means little bit separation is there, but that separation we have to make as 0. So then this line will be touching the graph. Okay, this line will be touching the graph. So you can say that A and B are same point, but I am showing it different. A and B are same point. A and B are same points. then what will happen? You can say that delta x is almost 0 or delta y is almost 0. So the change in x or change in y is going to be very, very small or negligible changes, right? Very, very small changes. So this delta y by delta x, when we write this delta y by delta x, this ratio, now we will apply the concept of limit. Limit you will be studying in maths. Limits you will study in this math. So this ratio delta y by delta x, when delta x tends to very, very 0, now this line becomes tangent. This line is now called tangent line. Tangent line. Okay, it's a very, very small, very, very small change along x, that is dx, and very, very long change in y, that is y dy. So this delta y has become dy and delta x has become dx. So this is called dy by dx, and this is still tan theta only, but the angle theta is angle made by this tangent line now. Okay, that is important to note. Now this angle is the angle made by tangent line. So here this is called slope of tangent line. Slope of tangent line. Tangent line. It is not the slope of secant line. Slope of secant line is delta y by delta x. This is dy by dx, that is slope of tangent line. Clear? Are you clear about this? Yes? Yeah. So this is the meaning of dy by dx. This is the physical meaning of differentiation. Physical meaning of dy by dx. This is the physical meaning of dy by dx. So once this concept is over, after that you have to learn just the formulas, because in maths you will be understanding in more detail about what is differentiation, what are the different formulas of differentiation, and note that these derivations of different formulas of differentiation can be understood only when you study limits. So in maths you will study limits and then you can apply that. So one basic formula I will show derivation that you can understand. After that, other formulas derivation in maths you will be studying. Okay. So suppose I want to do the differentiation of x square with respect to x. Okay. So here this is the y. Okay. Note that we want to differentiate y with respect to x, and the y is nothing but x square. Y is a function. What will be the differentiation of this y with respect to x? What is the differentiation? So let us understand the differentiation. Okay, so first of all, y is equal to x square, we know that. Now suppose you change little bit x, so y will also change. So let us change x plus delta x plus delta x whole square. So y will become y plus delta y. Okay, so let us take this as equation number 1 and this is equation number 2, and now you do 2 minus 1. 2 minus 1 you do, so y will cancel, you will get delta y, and here you will get x plus delta x whole square minus x square. After this, what you will get? Try to do this calculation. So a plus b whole square, now we can open this. A square plus b square, a square plus b square plus 2ab minus x square. So x square terms cancelled. So delta y, we got this as delta x whole square plus 2x delta x. Now I will divide delta y with delta x. Let us divide that. So delta y by delta x will become, if I divide, so delta x whole square by delta x will become 1 delta x. Here it will become 2x. So with delta x we have divided it. Now let us apply the limit. So this is the new concept of limit which you have to learn. Of course in maths you might have studied that. So now apply the concept of limit. Delta x tends to 0. Both sides we have to apply. Apply the concept that limit delta x tends to 0. So when you apply both sides this concept of limit, what you will get is this becomes dy by dx. This is what is dy by dx, right? Because delta y by delta x is secant, slope of secant. But when you apply the condition delta x tend to 0 means both the points C and B become the same point, then that line become tangent. Slope of tangent is dy by dx. And here you try to substitute delta x 0. So here if I substitute delta x first time 0, and that remains as 2x. So that is what we get as 2x. That is what you get as 2x. So y square differentiation, y is x square. X square differentiation with x, we know the formula. Yesterday we have seen the power you keep to x power 2 minus 1. So we got 2 into x power 1, that is 2x. So how this formula came? This formula is coming derivation of this. So this is the idea behind differentiation. So differentiation of all the formulas you have to remember. So now I will write few important formulas for differentiation. Differentiation of this x power n already we have seen, but still let us write this n into x power n minus 1. Second formula, differentiation of sin x. Differentiation of sin x with respect to x becomes cos x. Differentiation of sin x is cos x. Differentiation of cos x with respect to x becomes minus sin x. Differentiation of tan x with respect to x becomes secant square x. Then differentiation of secant x with respect to x becomes secant x tan x. Differentiation of cot x with respect to x becomes minus cosecant square x. Differentiation of cosecant x with respect to x becomes minus cosecant x into cot x. So these are basic differentiation of trigonometric function, which we must know. Okay, if you want to solve little difficult question, we should know the differentiation formulas for trigonometric function, polynomial function. Then there are some other function, log function and exponential function, that also we should know. So log function, differentiation of ln x. Ln x is log base e, that differentiation is 1 by x. And differentiation of a per power x dx is a per power x ln a. Okay, so what is ln a? Log, do you know about log? Yes. Do you have some idea about log? No idea. Okay, so what is log? Very briefly, I will explain here meaning of log. Suppose 2 per power 3 is equal to 8. Okay, so we can write the power 3 as log base 2 8. This is what is log. Okay, so log is a method of expressing the power. 2 per power 3 is 8. 3 can be written as log base 2 8. Okay, or the reverse also you can do. 2 per power 3 is equal to 8. Okay, now here what is log base e? Let's understand that log base e. So log base e, let us say this is y is equal to x. That means again this base power x will be y. Note that. So y is nothing but this base power x. Just like here, the base power 3 become 8. Same way, right? So this base e power x becomes y. So what is the value of e? E is a irrational number. E is a irrational number. Irrational number. And the value of e is nearly 2.718 something. Okay, dot it will continue, you know that it's a rational number, but approximately it is 2.718. Okay, it's like pi is a rational number, 3.14 continue, like that it is. Okay, irrational number. Okay, so this is the idea about this formula. So these are differential formulas of differentiation, we should remember that. Now, how to solve differentiation problems? Some properties of differentiation we should know. There are few important properties. Properties of dy by dx. Properties of dy by dx. So first property is that differentiation of any constant differentiation is always zero. Constant differentiation is always zero. Second property is that when you are doing differentiation of two functions y1 and y2, then you can separate it also. You can separate it like this. Okay, you can separately do the differentiation. Even if there is a minus here, that minus can also come out. Okay. So this is the property. We can apply this property. Then what is the third property? Third property is called some constant is multiplied, let's us say. So dy by dx, some constant, let us say capital A, is multiplied with y. So A is a constant here. So in this case, the constant can come out and it will become dy by dx. So constant has to be taken out of differentiation. Okay. Then property number 4. If you have to do the differentiation of product of two functions, so there are two functions which are multiplied. So this can be done by leaving the first function out and differentiating the second function, then plus leave this second function out and differentiate the first function. This is called product rule. This is called product rule. Product rule. So today I will share you some links on this basic maths which you can work out on the online test. Okay, because without going through the basic maths, you will face difficulties. Okay, so some practice is needed here. Then quotient rule. Quotient rule. So differentiation of division of two function y1 y2. This is given as second function square. Second function square. Leave the second function. Differentiate the first function minus leave the first function, differentiate the second function. This rule is a quotient rule, division rule. So after you understand all these 5 rules, then the most important rule comes, which is called chain rule. So these rules 5 are fundamental rules. So mostly the students of NEET, they do not have proper idea about these rules and they do not know how to apply these rules for complex problems. That is where they get stuck. So once you know these rules, you can see its application. One or two application I will show also. And the last rule also, let us note rule number 6, which is called chain rule. Chain rule says that suppose you want to differentiate a combination of function. For example, suppose I want to differentiate, uh, let us take for example sine of 2x plus 3. With example I am explaining sine differentiation you want to do. But here it is not the differentiation of sine x, because sine x differentiation is cos x, you know that. But this is not sine x, this is sine something which has x term, but this is not sine x. So differentiating sine of this directly we cannot do. So what is the method? The method is like this. Let us write that differentiation of sine, whatever this is, whatever that is, you have to differentiate with that thing. Then differentiate that thing with respect to x. Okay, this is what is called chain rule. So in chain rule, whatever this it is, it doesn't matter whatever this term it is. Of course, these and these terms are different because this is 2x plus this, some other term is there, and with respect to x you want. So whatever it is, you differentiate with respect to that thing only, and then differentiate that thing with respect to x. Why? Because differentiation of this thing will get cancelled, and the same remains. It doesn't change. But this is a way of writing this. Okay. So differentiation of sine of this with respect to x can be written as differentiation of sine of this with respect to this, and differentiation of this with respect to x. So if you do that, then things will become easy, because this is 2x plus 3, 2x plus 3, 2x plus 3. Okay. So now let us apply that. So differentiation sine of this with respect to this can be written as cos of this. Cos of this. This means that whole. Cos of this. Okay. That become cos of 2x plus 3. Then multiply. Now this differentiation can be broken into two parts because this has two terms. So first time you differentiate 2x with respect to x, and the next time you differentiate 3 with respect to x. Like that you break it into two parts. Now what will happen if I break it? First is this cost, this remains as it is, cos 2x plus 3. Now here the first term differentiation, when you do, 2 is a constant which is multiplied with x, 2 you take out, then it is dx by dx. And note that this constant differentiation is 0, constant differentiation is 0. So now from here, and note that dx by dx becomes 1 because dx can be cancelled. So that becomes 1, 2 into 1 is 2. So you can write this as 2 times cos of 2x plus 3. Are you clear about this rule? Yes. Yes. This is the chain rule and the most important rule. Okay. Chain rule is the most important because mostly questions are based on this. So this is what is differentiation. What is the meaning of differentiation? From the graph, which is the slope of tangent, and then what are some of the important formulas of differentiation, and what are the properties of differentiation. Then you can solve any question. Okay, let us take a question. Let us take a question. So suppose a particle is going, we are seeing application based question. Particle is going and its position depends on time, like 2 sine pi t, 2 sine pi t. Find the position, velocity, and acceleration t is equal to 0.5 second. Do this calculation. Any answer? Next position. Substitute time here. So 2 sine pi into 0.5. 0.5 means half. So 2 sine pi by 2. Note that this pi means angle is in radian. Pi by 2 means 90 degree. Sine 90 is 1. So this is what is 2. Units will be in SI units, so meter. Clear. So at 0.5 second you substituted and you got the position as 2 meter. Now we have to calculate velocity. To calculate velocity we need to first do differentiation. Velocity is equal to dx by dt, and x is here 2 sine pi t. Pi t is like the angle with respect to t. So what we need to do here, 2 is a constant, take out first, then differentiation of sine of pi t with respect to t. Okay, sine of pi t with respect to, now chain rule we have to apply here. Apply chain rule. So v we will write as 2 differentiation of sine of this with respect to this, and then differentiation of this with respect to t. Okay, this is how we will apply. So from, yeah, 2 cos square pi t. Okay, let us take that. So 2 differentiation of sine will give us cos of same thing pi t, pi t, pi t, pi t, pi t. Okay, now differentiation of pi t will be what? Pi will come out, and differentiation of t with t is 1. So this I can write as 2 pi cos pi t. This is what you are getting. Check this. Are you getting this? Or pi square you are getting? Pi square will not come. Sine differentiation become cos, whatever that pi t. Then pi t differentiation with t, pi is constant comes out. Time differentiation with time become 1. So 2 pi cos pi t. Clear? Okay. Then you substitute values. Okay, time value you substitute and tell me how much. So velocity 2 pi sine of cos pi, again this is 2.5. So cos pi by 2 means it is cos 90 degree, and cos 90 degree you know it is 0, so answer is 0 because cos 90 degree is 0. Okay, then again acceleration we want. Again acceleration means you have to do differentiation further. Now further differentiation we have to do to get acceleration. So this is velocity we have got. This differentiation again you do dv by dt. So when you differentiate the constant term, you take out first. 2 pi I have taken out. Now differentiation cos of pi t with respect to t. Chain rule we have to apply again. 2 pi comes out. Cos of this with respect to this, and then differentiation of this pi t with respect to time. Again solve it. Tell me now what will this come. This you have to do again. Acceleration 2 pi. Cos differentiation is minus sine, right? This will come minus sine pi t. Then here again pi comes out. Time differentiation with time become 1. Now check that. Minus will come. Time differentiation is 1 pi. So minus 2 pi square. Here pi square is coming. 2 pi into pi. Okay, minus 2 pi square sine pi t. Correct. Check this. Right? Clear? Okay, then you substitute values of time. Time again 0.5 means sine 90 degree will come. So minus 2 pi square sine of pi into 0.5. Sine 90 degree is 1, so minus 2 pi square. That's all. And generally pi square is sometimes taken as tan. Note that. Approximation it is. So pi square is taken as tan means acceleration will become minus 2 into 10 is 20. So acceleration is almost equal to, not exactly, nearly equal to 20. Otherwise minus 2 pi square is the correct answer. Okay, this is how we can solve problems of differentiation. Question involving differentiation with kinematics we will solve like this. Okay, done. So the differentiation concept is over. Now you can solve out problems on this. Then let us go to the slope concept is over. What is now double differentiation? So let us say that this is a graph which is going up down like this. So now you need to understand that here the slope, if you take slope here tan theta, so dy by dx is positive because theta is acute angle. Tan theta is going to be positive. So note that for this region of the graph up to here, the slope dy by dx is going to be positive. dy by dx will be positive. But as soon as you go at the top point here, the tangent will become parallel to x-axis. So theta becomes 0 here. Theta becomes 0 here. As theta becomes 0, here dy by dx will become 0 because tan theta is 0. So dy by dx is 0 at this point. What about this side? If you see right side, this side graph, up to this much you can take to here. Anywhere this point you take. Suppose if I take anywhere this point, draw the tangent. Tangent, when you draw, this tangent will make this angle theta. Okay. Now this angle theta is obtuse angle, and for obtuse angle tan theta is negative. You should know that tan theta is negative. So in this region, in this entire region, dy by dx is going to be negative. Okay. So dy by dx is positive. So I am writing here dy by dx is positive up to this point. Then 0 here, and then dy by dx is negative, negative here also, negative. Now when it comes here bottom point, again the tangent will become parallel. Again dy by dx will become 0, right? Because theta is becoming 0, so dy by dx again become 0. Okay. So here dy by dx is 0 again. Now again the same story will happen when it is going that side, so it is going to be again positive. So when you go this side of this graph, up to here again it is positive. Dy by dx will be positive. Positive, 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 positive. Again here when it comes, it will become 0 because again it become parallel to x-axis. So tan theta is 0 because theta is 0. So like this will happen, no? You can understand this. So in this region, slope is positive. Here slope is 0. In this region, slope is negative. In this region again positive. Like that it repeats. Okay. So what is important to understand is that, okay, slope is positive, but slope is increasing. Note that when theta increases, slope increases, and theta decreases, slope decreases. So suppose if I am going from here to here, what is happening? Let's understand that. Slope is increasing or decreasing? Theta is increasing or decreasing? Can you tell what is happening? Theta is increasing or decreasing? What is happening? Theta is increasing or decreasing? Theta is increasing or decreasing? Here some angle was there. Now angle has become 0. Theta has increased or decreased? Yes. When you go from here this way, when you are moving, as you are moving this way, theta is increasing or decreasing? Tell me. Theta is increasing or decreasing? Here theta is there, let us say 60 degree, and then 0. Then how increasing? Here what is angle? Let us say angle is 60 degree. Here angle is 0 degree. So theta is increasing or decreasing? Ah, because here some value of angle is there, and here it is becoming 0. So slope here will be positive, and then slope is becoming 0 means slope is decreasing. We should note that. As you move like this, slope is decreasing. Okay, slope is decreasing. Slope decreases. What about this side? When you go here, negative, hmm, negative. Now 0 to again negative means again slope is decreasing only. 0 to here 0 to negative, now slope has become negative means it has decreased only. So still slope is decreasing only. Okay. Now from this point onwards, you see negative, it is increasing and it is becoming 0. So from negative to 0, slope is increasing. So here or in this region, here there will be a point here. This we need to note. There is a special point here where this is happening. So here to here, slope is increasing. Slope increases. Okay, and here to here as well. In this region, up to this point, when you go, slope is decreasing. So slope decreasing or slope increasing means how slope changes with respect to x. So this is differentiation of slope with respect to x, and slope itself is called dy by dx. dy by dx, slope itself is dy by dx. So differentiation of dy by dx is called double differentiation. D square y by dx square, this is called double differentiation. So now you can understand that here slope is decreasing means double differentiation is negative. That is what the important point is, that negative entire region double differentiation is negative. Double differentiation d square y by dx square. Here in this entire region double differentiation is positive. D square y by dx square is positive. Are you understanding this? Yes. See, you are going now along x-axis. You are moving. So as you are moving along x-axis, you first see here how the slope is changing. So the rate of change of slope you are seeing. Slope already you have studied. How slope you can calculate slope. But how does the slope changes? How does the slope changes with respect to x? As you move, how does the slope changes? That is what we are looking at. Okay. So how does the slope changes when you move? Y changes with respect to x, that is called slope, that is dy by dx. How y changes with x, that is called slope, dy by dx. How slope changes with x, that is called double differentiation. Okay, so as you are going from here to here, as that means as x is increasing, so first you have seen the slope is, what is happening to the slope? Slope is decreasing, and up to here slope is decreasing. So slope is decreasing means double differentiation is going to be negative, right? Double differentiation negative means slope is decreasing, and from here to here slope is increasing. We are not talking of y. We are not talking of y now. Y increases, y decreases, that is what is dy by dx. But now we are talking about dy by dx, which is the slope. How dy by dx is changing. So here dy by dx is increasing. So increasing, decreasing of the slope gives the idea of the shape of the graph. Okay, that is why we need double differentiation. So if you now look at this graph, for example, now if you see this type of graph, this shape is called convex. Convex. And in this convex shape, double differentiation is negative. Double differentiation negative means slope decreases. Okay, the square y by dx square is negative. Negative. Double differentiation negative means slope decreases. Slope decreases with respect to x. With respect to x. That means as x increases, slope decreases. That is the idea. So this shape is important. Sometime if you calculate double differentiation and suppose double differentiation comes negative, means the shape of the graph is convex. Similarly, suppose the graph is like this. This shape is called concave shape. Concave. Concave. And what happens in this? In this case, double differentiation is positive. D square y by dx square is positive. What does that mean? That means slope increases. Slope increases with respect to x. With respect to x. So as you increase x, slope increases. Okay, and this type of shape is called convex shape. So the graph is made up of either concave or convex shape. But there is a point where double differentiation is zero. where the shape of the graph is changing. For example, suppose if the graph is changing like this point. If you see this point, before this double differentiation is negative. After this double differentiation is positive. So what about this point then? Definitely double differentiation must be 0 at this point. Double differentiation is 0 at this point. This point is known as point of inflection. This is called point of inflection. Okay. So what is the double differentiation gives? Double differentiation gives the shape of the graph, whether it is concave or convex. It gives you the idea of that. Clear? This is a very important tool because many times you have to plot the graph and you do not know how it is increasing, how it is decreasing. So it's a very important tool. For example, suppose, let us say, for example, suppose if x is increase, y and x are increasing graph and non-linear graph. Non-linear graph means it can increase like this way also, right? And another way it can increase is this way also. It can increase. Both are increasing only. Both both are increasing, but the shapes are different. This shape is concave. Okay, that means double differentiation will be positive, and this shape is convex, means double differentiation will be negative. That is the only way you will be able to find out. So for this graph, double differentiation will be positive, and for this graph, double differentiation will be negative. Okay, right. So up to this much we can wind up for today's class. Now, tell me. Yes. Slope is decreasing. Double differentiation negative means slope decreases. Double differentiation positive means slope increases. Right? That is what it means. And similarly, suppose if differentiation is positive and negative, let us say that dy by dx is positive. Suppose if I say dy by dx is positive means y increases. Y increases with x. Y increases with x. Similarly, if I say dy by dx is negative means y decreases with x. Y decreases with x. Similarly, if I say double differentiation is positive means double differentiation means differentiation slope with x. So slope increases with x. Similarly, double differentiation negative means slope decreases with x. Clear?